Okay, so today we are starting with inclined planes. So motion in inclined plane, motion of an object in an inclined plane. Okay, so write down the topic, the motion of an object in an inclined plane. The Matrukava, motion of an object in an inclined plane. Okay, so what is the meaning of an inclined plane? Inclined plane means now if you take a ground, for example, it's horizontal, right? But rather we have a inclined plane, means it makes some angle with the horizontal. So we have a plane, it could be the floor, or it could be a board, or it could be a road, okay? Anything, but it is making some angle with the horizontal. It is making some angle with the horizontal, so we can call it as a inclined plane. So today what we are going to discuss is, we are going to discuss the motion of an object in an inclined plane. So we can start with the question. Okay, so you can start writing this question. An object of mass simple m. So an object of mass simple m is placed on a is placed on an inclined plane which makes an angle theta with the horizontal, an angle theta with the horizontal, and the object is released and the object is released from rest. Okay. Okay. So this is the question, an object of mass m. So actually this describes the scenario, and after I'll draw the figure and then I'll give you the questions. Okay. An object of mass simple m is placed on an inclined plane. Here I had to mention on an it's better if I mention on a smooth inclined plane. On a smooth inclined plane which makes an angle theta with the horizontal and the object is released from rest. Okay. An object of mass simple m is placed on a smooth inclined plane which makes an angle theta with the horizontal and the object is released from rest. So I will draw the figure now. So here we have an inclined plane which makes an angle theta with the horizontal. Okay. So we have a mass. Let's consider like a box. Okay. The mass is m. Okay. So it is being placed on this inclined plane. Okay. So the first question. Number one. First question. Draw the free body diagram. Draw the free body diagram. Free body diagram. Nidahas balasatana. Draw the free body diagram of the mass. Simple. Okay. So you had to mark. So the free body diagram means we know we had to mark all the forces acting on the mass M. So we had to mark all the forces acting on M. Okay, quickly do this. I won't give more than 1 minute because there are actually only two forces acting on this mass. So you have to mark those two masses. Okay. Okay. So check your answer, check whether your answer drawing are correct. So first the weight will be there. The gravitation attraction force is always vertically downward mg. And then the normal reaction force will be there. So it's perpendicular to the contact. So here this is R normal reaction force. Okay, so these are the two forces acting on this mass. Okay. And second question, find the, now if this plane is smooth, right? If this is smooth, what happens if I keep on this, it will definitely slide down because due to the earth attraction. Okay, due to earth's gravity, so it will uh, slip down. Okay, so second question, resolve the weight of the mass, solve the weight of the mass in two perpendicular directions comma, one is parallel to the inclined plane, parallel to the inclined plane, and the other component one is parallel to the inclined plane and the other component is perpendicular to the inclined plane. Okay, so quickly resolve this. So if you want to resolve this, you have to get the angle. Now the only angle I have given here is theta. So somehow using the geometry, you have to relate this weight with the theta and then you have to resolve into two perpendicular directions. Okay, start. Okay. Okay. So here now we know the weight acts vertically downward, right? So if I extend this line, okay, so here this is horizontal, so therefore this angle will be 90 degrees because weight acts always vertically downwards. So if this angle is theta, then this angle will be 90 minus theta. Therefore, this angle will be 90 minus theta. So I draw this part a little bit bigger here for the purpose of explanation. Okay, so here you can find this mg will be there. Here this is r. Okay, so you can see this angle is 90 minus theta. So this angle 90 minus theta. Therefore, this angle 90 minus theta. So that this will be theta. This angle will be theta. Okay. Okay. So then the plane will be there. This is the plane. Okay. This angle is theta. Okay, and then we want to resolve this weight into two perpendicular directions. One is perpendicular to the plane. So this is the inclined plane. The one is has to be perpendicular. The other one is parallel. So we can resolve in two such directions. One is in this direction. So this angle is theta. So therefore towards the angle, so this component will be mg cosine theta, mg cos theta, and the other component will be in this direction. So that it will be mg sine theta. Okay. Uh, the new batch students, if you don't understand this resolving part, don't worry. Within couple of weeks, we will, within this week, we will be starting the vectors. So within 2 weeks, we will be studying this vector resolving. So at the moment, if you don't understand this, it's totally fine. Okay. Now just keep in mind that any force we can divide into two components. These two components are perpendicular to each other. Okay. Okay. So quickly mark this. You don't need to draw the another diagram. In the same diagram, you have to mark. I drew this because here the difficult to explain the angle because it's small. So for that reason, I drew it again. But anyway, you can mark the angle and resolve it in the same diagram that you drew already. Okay. And the third question, right on the third question, find the acceleration of the object. 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 Okay, trying to find the acceleration. You have 60 seconds, and if you got the answer, you can share it to me. You can just type also. the answer. Okay, I got the correct answer from Hirosh. Good. Okay. So here, if you consider this mass, so if you consider this direction, the perpendicular uh, direction to the plane, in this perpendicular direction, this side is R is there, G is there, and G cos theta is there. This may be in equilibrium because in you won't find any motion in this perpendicular direction. But due to this mg sine theta component, due to this component, what happens? This mass will accelerate downward because there is no only this force is there. So that means that is an external force, and there is no any other force in this direction to counterbalance this. Therefore, definitely this will escape. So if you have a smooth plane, okay, if you have a smooth plane, you will never be able to keep an object on it. It will always, what happens? Slide down the plane, right? Because there is no any force to counterbalance this weight component. Okay, so therefore I can apply. So using F equals ma to the mass to the object. Uh, Using F equals ma to the object. So yeah, so you have to mention the direction. So here the direction is, this is angle theta. So, so the direction will be, this is theta in this direction, right? We draw a line like this, okay? So this is parallel to this. Therefore, this angle theta means, so this angle also will be theta, alternate angle. Okay, so here, then in this direction, I can use F equals ma. Only the force acting on this mass is mg sine theta. Mg sine theta equals to mass times acceleration. So the mass cancel out. The acceleration we get a equals g sine theta. Acceleration is equals to g sine theta. Okay, so you can see the vertically downward acceleration is, we know, gravitational acceleration, right? Then therefore in theta decrease this direction, you have to actually resolve this into this direction. So it is g sine theta. So the acceleration is g sine theta. Fourth question. Obtain an expression for the normal reaction force. Obtain an expression for the normal reaction force. we try to get an expression for R in terms of m and g. Okay, so it's simple. If you consider this direction perpendicular to the plane, in this direction, there is no any motion. The object is moving in this direction, but there is no movement in a direction perpendicular to the plane. So according to Newton's first law, the force has to be balanced. Therefore, we can write considering the force equilibrium, or you can just write considering the equilibrium of the object in the direction perpendicular to the inclined plane. So if you consider in this direction, we have to consider a direction. I will consider this direction, and this angle is theta. So I consider in direction. So R is there, and then mg cos theta is in the opposite direction. Mg cos theta. So this should equals to 0. As forces balance, no resultant force. Therefore, R equals to mg cosine theta into cos theta. Okay. So here you can see this acceleration. This acceleration only depends on the angle. If you increase the angle, what happens now? Sine theta variation you should know, because sine 0 is 0. Sine 0 is equal to 0. Sine 1, sine 90 equals to 1. Sine 0 is equal to 0, sine 90 equals 1. So that means if you take the sine graph, so y equals sine theta and this angle is theta, let's say. So it's 0 and then it will be 1. So that means 0 to 90, the sine value is increasing. This is the variation. Here 90 degrees, here 180, 0. It will go like this. Okay, so but we are interested in 0 to 90. So from 0 to 90, because if you take an inclined plane, if you take a plane, so theta is 0 means, so this angle is 0 means it's horizontal. Then the acceleration becomes 0, because sine 0 is 0. So therefore acceleration will be 0. That means if the plane is horizontal, then it won't accelerate. It's clear, right? It won't accelerate. But when you increase the sine theta, A is increases. So A is proportional to the sine theta. From 0 to 90 degrees, sine theta increases. Therefore, acceleration increases. So if I take like this, it will have a small acceleration. Like if you have a small inclination, if the inclination is small, the acceleration is small. But if the inclination is large, acceleration is large. You see the difference. So if a small inclination, it takes longer time, short time. Okay, because the acceleration varies with the theta. Okay, and this acceleration does not depend on the mass. The acceleration does not depend on the mass. So you can write down these 2 points. Okay. So the acceleration of the object does not depend on the mass. Okay, that's the first thing. And second one, you can write acceleration increases with the inclination or the angle of the plane. Okay, so the first point, write down acceleration does not depend on the mass. Now, here I'm saying the acceleration is does not depending on mass. It's something like I'm teaching ABCD. It's actually basic thing, right? දැන් ඔයාලා මේකට අලුත් හින්දා ඔයාට ඒක අලුත් දෙයක් විදිහට වෙන්න පුළුවන්. It could be a new thing, but with the practice, if you now you are going to live with physics for 2 years, right? So in that time, so these facts will be like very basic fundamental things, right? Okay. Anyway, so here acceleration does not depend on the mass. And second thing, acceleration increases with the uh, increasing of the angle of the plane. Okay. So you can write down those. Okay, so let's move on to the so this first question and the second one. So the second case is now in the first one you wrote right, an object of mass m is placed on a smooth inclined plane which makes angle theta with the horizontal. In that entire sentence, everything will be the same, but only the difference now we are going to make is smooth plane change to rough plane. Okay. So the object of mass m is placed on a rough inclined plane which makes an angle theta with the horizontal, and the mass is released from the rest. And the mass is released from the rest. So the same question, but the only thing you have to change is the word smooth. You have to change it to rough. That's the only change you have to do here in this question. Quickly write down and then draw the figure. And also the first question is draw the free body diagram of the mass m. Okay, if you finish, you can send me a drawing of the free body diagram. Either you can send it through WhatsApp or the Zoom chat. I need each and every one of you to draw and send your, I mean, the your drawings. Okay. Hirosh, I finished. Abhishan, you finish? What about you, Zufar? Don't take much time. Zufar, can you send it to the TKI? Is it possible? Because it's difficult for me to be open up from here. Or else you can send it to me through WhatsApp. Okay, gotcha. Okay, weight marked correct. Normal reaction force correct. But the friction, there's a small thing you have to change. I will explain that. First, I will see everyone's drawing. Hirosh, Atika, and Abhishani, please send your workings. It's okay to be wrong. Send to catch it. ඔක්ම කරලා තියෙන ඔක්කොම හරි හැබැයි මේ පොඩක් පිළිවෙල අඩුයි. Have to draw neatly, okay? Now the normal reaction force should be perpendicular to the plane. Concepts all okay, but the neatness is only the issue. Okay. Abhishani, Atika, You can send your workings through WhatsApp or if you're sending through the Zoom, send it to the teacher. Yeah, maybe because of the rain, I think. Is it raining your side? By the way, I appreciate if you can like unmute and interact with the class, so that way the class is more, uh, find interesting. Okay, so here I will draw. So starting from the weight is vertically downward in G, and the normal reaction force will be perpendicular to this, so R. And then since this is rough, now we know if the plane is not rough, what will happen? If I keep the object, it will slide. It tends to slide down, right? But so the tendency of movement in this direction. So Earth push the object this direction. So that therefore here we can see, we can resolve this weight into two perpendicular directions. One is this mg cos theta, and then this is mg sin theta. So now mg cos theta component can't do anything because it's the plane is there, so normal reaction force it's balanced. But due to this one, what happens? It pushes. There will be external force, right? Therefore, equal and opposite friction force will be there acting on the mass. So here it will be this direction. F. F will be here. Okay, so this is the free body diagram. Okay, because the friction should be there. The friction is there because the plane is rough. Okay. Right. So first, let's assume this mg sin theta is less than the fs. Okay, so that means the object is now balanced. It's not moving, right? So equal and opposite friction force will be there. So the second question, obtain expressions for normal reaction force, normal reaction, normal reaction force for normal reaction force and friction if the object is in equilibrium. Equilibrium, or I can say balanced. Samatulita, equilibrium. Balance is not a good word, but to guess the meaning, Just only for this time you can. The best word is equilibrium. Samatulita. Okay. Okay. Obtain expressions for normal reaction force and friction if the object is in equilibrium. Okay. Yes. Is it possible for you guys to text to the TKI because I can't from here something went wrong with don't know whether new update or something. If I try to wave the chat, read your turns to 90 degrees. If possible, it's to TK, otherwise fine, you can send it to the same. Okay, thank you, sir. Hirosh. Okay. So if the object is equilibrium means the forces has to be balanced. Okay. The net force will be zero. So first you can consider a direction in the perpendicular direction to the inclined plane. Okay. So considering the equilibrium, so first we are considering this direction. So this angle is theta. So in this direction we have r and opposite direction mg cos theta. So this has to be zero. The resultant force is zero because there is no any movement in this direction. Therefore, R equals mg cos theta. And then we can consider direction parallel to the plane. So here downward we have mg cos theta minus f. F is in the opposite direction. So the net force has to be zero because it's in equilibrium, not movement at rest. Therefore, F equals mg cos theta. Okay. 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 So here, after that, so I'm not going to give a question. Let's see. Uh, I'm going to divide these two equations. Okay. If so, this equation one, and then this equation number two. So then 2 divided by 1. 2 divided by 1. Then I have f over r is equals to mg and mg. Here this should be sine theta, no? Here mg sine theta. This one mg sine theta. This is also mg sine theta. Okay. Please correct me if I did any mistake. Okay. F over r equals to, so mg and mg cancel, so we get sine theta divided by cos theta. Therefore, f over r is equals to tan theta. For r is equals to tan theta. Okay. Right. And the next thing I'm going to write that is fact. We know f is always less than or equal to fs. The friction force is always less than or equal to the maximum friction force between these two surfaces, contacts. So the limiting static friction. Friction force is always less than or equal to limiting static friction. F is equal to Fs when comes to the limiting condition. Okay, that means just now for example, if you consider this case, when you have IDF and if you increase this force gradually, so if this F is equal to Fs, let's say Fs has a maximum value, no? Like for example, 10 Newton. The Fs is 10 Newton. 10 Newton whenever that moment, that instance, we call the limiting condition. That means if the F just increase than the Fs, it will start to accelerate. Okay. So the moment or the condition just slightly before, now for example, if Fs is 10 Newton, then if you apply a force of 10.0000001 Newton, also enough to make this move because the maximum force is 10 Newton. So that means this condition, we say it's the limiting condition. Limiting condition is actually this Newton, 0.00 Euro. 10 Newton is the limiting condition. You got it will start to accelerate. Okay. So the limiting condition, it means සමතුලිතාව බෙදෙන්න තියෙන ඔන්නමෙන්න අවස්ථාව. That the slight difference, to break the equilibrium. Okay. Can I say just like, for example, if this is maximum force is 20 Newton, then if you apply a force of 20 Newton, that is the limiting condition, right? So then if you slightly increase the force, it will accelerate, right? Okay. So here we know that F is always less than or equal to Fs. Okay, so F is therefore less than or equal to, we know Fs is equals to what? Fs equals to nu s times r. So I write nu s times r. I take this r to this side. So F over r is less than or equal to nu s. Okay. And therefore, F over r tan theta. The tan theta should be less than or equal to nu s. Okay. That means if this is in equilibrium, there is a maximum value that tan theta can take. Okay. So that means if you take the theta, so if you subject theta is less than or equal to tan inverse, take the tan to the other side, it becomes tan inverse mu s. Tan inverse mu s. Okay. So therefore the theta has to be less than or equal to this value. This is actually an angle. Okay. Yeah. Tan inverse. Yeah. This is an angle. So there should be a maximum angle. We will discuss about this later. I'll give you another example after that. We'll discuss. Okay. So here you write down this. So let's say here tan inverse mu s is equals to, let's say, is equals to alpha. Therefore, then I can say right here theta should be less than or equal to alpha. Okay. So this alpha is the maximum angle that the inclined plane can take so that it will save the equilibrium. Now I can explain it like this. So here I have this plane, inclined plane. Okay. So the object. So then I'm increasing the angle. So I'm increasing the angle. Okay. And when this angle gets equal to alpha, it will break the, when it's equal to alpha, it is the limiting condition. If the angle exceeds alpha, it will break the equilibrium and slides. So if the object has to be in equilibrium, the theta has to be less than alpha. Okay. Okay. First, write down this. Once you're done writing, let me know. Raise your hand. So after that, I'll be done. Hirosh, did you understand? Ko Hirosh can respond to kind. Aviation, did you understand? I asked you whether did you understand about this fact that a theta has to be less than or equal to alpha. Alpha is the angle that corresponds to tan inverse mu s. Okay, quickly write this down and then let me know. I'll give you the explanation. You should send to the TKI. Okay, so it should be easy for me to view from here the desktop. Send it. But I didn't get it. Check surely. Yeah, great class. You sit here and learn. Do you want to learn physics? Do you want to learn physics? Yeah. Then sit there. Sit in the chair and go. No. I want to put glass. I want to put the glass. I want to put the glass. Okay, enough. Go. Bye. I want to put the glass. I want to put the glass. Please. I want to put the glass. I want to put the glass. Okay, are you finished writing? Huh? Huh? No, no, no. Put it in order. Put it. Write it. This one, this one. La, 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 la. What are you doing? What is that? What is that? Which one have finished writing? Adam. I want to see Adam. Hi, Peppa. Shh, don't shout. It's not she actually, it's he. I want to see Adam. You want to see Adam? Yeah. See, can you see now Adam? Yeah. Okay, okay, done. Okay, so let's write down. Okay, so here, so I hope you wrote all this. Okay. So here alpha is the angle corresponding to tan inverse nu s. Okay. Now, for example, nu s is, let me explain here. Now, nu s is the static friction coefficient, right? So it's something have value like 0.2 or 0.4, 0.5. Let's say 0.4. Yeah. Okay. So the tan value, we know the tan of an angle. Okay, darling, go that side. Yeah. You sit there in the class. Is okay. So the tan x value, we know it is varies from that value is less than or equal to 0 and infinity. Okay, so less than or equal to infinity. So that range of tan is 0 to cockroach. Excuse me, guys. Give me a second. Okay, so the tan values we know 0 to plus infinity. But if you take the sine and cosine, sine x is plus 1 and minus 1. Cos x plus 1 minus 1. So this additional knowledge. Anyway, the tan is 0 to infinity. So that means there can be an angle. You know, tan 45 is tan 45 is equals to 1. Tan 30 is equals to square root 1 over root 3. So 1 over root 3 means it has some decimal value, right? 1 divided by a number, so you get some 0 point some number. For example, I don't know, 0 0.4, let's say, okay, or 0.56, I don't know, some value will be there, 1 over root 3, okay? Okay, so that means the new s, so you can find the inverse of tan. So there, now that means there could be a tan value, tan of an angle. Let's say, for example, tan 42, for example, or let's say tan 38 would be 0.4. Okay, that means 38 is 8 degree is the maximum angle that the inclined plane can take so that the object will remain equilibrium. But if the angle increase more than that, it will, what happens? Breaks the equilibrium and then slide down. Okay. Okay, so let's write down this. Here, write down here alpha is the angle. Here alpha is the angle that corresponds to tan inverse mu s. Here alpha is the angle that corresponds to tan inverse mu s. And alpha is the maximum angle. The alpha is the maximum angle that inclined plane can take. The maximum angle that inclined plane can take so that object remains equilibrium. Object remain equilibrium. In other words, write separately. In other words, uh, the object will remain stationary on the inclined plane if the angle of inclination is less than or equal to alpha. In other words, the object will remain stationary or equilibrium on the inclined plane if the angle of inclination is less than or equal to alpha. Okay. And then the next point right on. If the angle of inclination if the angle of inclination exceeds more than alpha, if the angle of inclination exceeds more than alpha, then the object will accelerate downwards. And the object will accelerate downward. Because if this angle will accelerate more, this mg sin theta component will be higher than the fs value. Therefore, it will accelerate downwards. So I can give if theta is less than alpha, object is in equilibrium. The object remains at rest. If theta is equals to alpha, so this is the limiting condition. Of the equilibrium. That means that is the maximum angle that the theta can take without breaking the equilibrium. So here you can. So this is the maximum angle. So then if I slightly increase, what happens? Just slight. Okay. So if theta is greater than alpha, object will accelerate down. Down the plane. The object will accelerate down the plane. Do you have any questions? I hope everyone understood well. Okay, so I'll give you a question. Okay, write down an object of mass 2 kilogram. An object of mass 2 kilogram is placed on a horizontal surface. Is placed on a horizontal surface. Is placed on a horizontal surface which makes an angle state the angle 30 degrees with the horizontal, which makes an angle of 30 degrees with the horizontal. Okay. Is placed, sorry, an object of mass 2 kilogram is placed on a inclined plane, sorry, a rough inclined plane, which makes an angle 30 degrees with the horizontal. First up, first up. Okay. The static friction coefficient, the static friction coefficient between the object and the inclined plane is the static friction coefficient between the object and the inclined plane is say 0.3. Okay. So the first question, draw the free body diagram. And the second question, determine whether the object will remains at rest or move. Determine whether the object will remains at rest or accelerate. I got a question from Billy for if theta equals alpha. If theta equals alpha, that is the maximum angle which secure the equilibrium. So if the angle is exceeds just slightly than alpha, then it will accelerate. So I have given you two questions. First, draw the free body diagram, and then second, determine whether the object will remains at rest or accelerate. Okay, so here's the free body diagram. The weight is pointing upward. The resolving part is not necessary. Right? You just need to, if they ask the free body diagram, you have to draw this arc, this 20 Newton, and these three. That's all. Okay. No need to resolve this. Okay. No need to draw these two parts. Okay. And here is this. So this is the free body diagram. Only these three forces on the object. Okay. Okay, good, very good. I got the free body diagram from Abhishani. Very nice. But here, this, as I told you, this components not necessary. If they ask the free body diagram, you have to simply mark the forces acting on it. So, normal reaction force, weight, and the friction. These are the three forces acting on this object. Okay, now you need to find whether the object remains stationary or will accelerate. Now to find that, now definitely you need to resolve this actually. So this 20 cos 30, so 20 sine 30. So the first thing you have to calculate, what is the first thing you need to calculate? Tell me, what is the first thing you should calculate? No. Here you need to calculate is the, okay. So one thing is you can uh, find with two logic. One is now in your uh, in our syllabus they expect you to find Fs and the unbalanced force, the 20 sine 30. 20 sine 30. You need to get this relationship either like this or this. If it's like this, then the object remains stable at rest. But if the unbalanced force is greater than the maximum force, then it this will accelerate downward. Okay. Or else you can go, consider with the alpha also. You can take the tan 30 value, or here the angle is 30, and then you can find the tan inverse 0.3. Okay. So, and then by comparing this two also, you can say, I mean, you get some value for this angle. You get an angle and you can compare with these two. But if in a question, if you get a question like this in your paper, they definitely expect this one. Okay. So here first you have to calculate the static friction force, the limiting static friction force. So Fs equals to nu s times R, right? But here R is equal to this direction and consider the equilibrium. So I can, or else I can write using F equals Ma, F equals Ma to the mass, and then you have to consider a direction. So I consider this direction 30 degrees, this direction. So in this direction we have R, in opposite direction 20 cos 30 equals mass is 2 kilogram, 2 into acceleration is 0, because in this direction no acceleration. Therefore R equals 20 into cos 30 is root 3 over 2. Therefore R equals 10 root 3 Newton. R equals 10 root 3 Newton. So then therefore we can find Fs. Fs equals to 0.3 into R is 10 root 3. So therefore Fs equals to 10 3 root 3 Newton. Okay. And the next thing we are going to find is mv sin theta. So 20 sin 30 is equals to 20 into sin theta. Sin 30 is half, so this is equal to 10 Newton. Okay. So then we can say this 10, 3 into root 3 is 3 into root 3 is something around, root 3 is 1.7 something. So it will be less than, definitely less than 10. So Fs is less than 10 Newton, or 10 newtons greater than Fs. Therefore, the object will slide down the, or accelerate, slide down the plane. Down the plane. Okay. Is that clear, everyone? Atika, did you understand? Okay, good. Okay, so we will conclude the session from here. In the next class, we will consider what happens if we have a pulley. Like we have a mass here, and then it's attached to a pulley, and then we have another mass. So what would happen? These things we will discuss in the next class. Okay, if you have any questions, then you can ask before we wind up the session. Okay then, so please go through the notes and study well. Good night. Take care.